As described earlier, the upper section now had a cement plug around the on top of the bad section of casing at 7,500, and a cement plug at about 3,000 feet where they cut and recovered that pipe. So a second intercept was required to go underneath that cement plug and address those perforations that were inside that upper section that were placed while trying to establish circulation behind the 5.5. We set a second whipstock inside the 7-inch casing. We directionally drilled off the face of the whipstock, working our way over towards the target well casing, and ended up making soft contact with the target well with our very first try. At that point in time, we pulled back out of the hole to pick up our milling BHA. And while running in the hole with our milling BHA, we encountered a whipstock failure. What ended up happening is the whipstock itself peeled itself off the backside of the casing, effectively putting the whipstock in the center of the 7-inch hole, 7-inch casing. This sealed off the open hole section down below. This is not uncommon in the industry with a whipstock and these types of failures. So thinking outside the box and how to salvage the open hole and intercept well that was just drilled, it was determined that the best course of action would be to run in the hole, retrieve that old whipstock, pull that old whipstock out of the hole, run back in the hole with a new whipstock, set that whipstock in the exact same position as the old whipstock, and continue moving forward. With that in mind, we changed up our processes slightly to be able to accommodate the precision required to set that new whipstock back in place. And what we ended up doing is we shortened up the probe a bit with our wireline gyro, the mechanism used to orient the whipstock. And we also kept the wireline gyro running real time so we can get real-time updates with tool faces, understanding the exact orientation of what that whipstock was then set. Once the whipstock was anchored and we overpulled our typical operation to ensure that the anchor is set in place, we then sheared off the whipstock with the shear bolt and began milling operations. We milled up the 2-inch lug that's on the top of the whipstock, and then once that 2-inch lug was milled up, the whipstock and the mills were able to transition in and off the face of the whipstock with no additional problems. We were able then to pull the whipstock milling BHA out of the hole, pick up the window milling BHA, run back in the hole, and effectively mill our window into the original hole target casing, the 5.5-inch casing. Once that window was then milled, we pulled that BHA out of the hole and went back in with a 2 7/8 tubing BHA, which was our re-entry BHA. We effectively entered the original 5.5-inch casing and was able to trip in about 2,500 feet unobstructed until we encountered what I would consider some slight fill. That slight fill was able to be circulated out to the prescribed depth, and once approved by CalGEM, the regulatory agency, we were able to start our cementing operations. The cementing operations consisted of multiple cement plugs being laid inside of that 5.5-inch casing, all the way back up to the window that was just milled. Once we were able to cement all the way back up to the window, we then continued with cementing operations by cementing up the open hole section and then into the 7-inch casing and effectively back to surface, completing this abandonment, this very complex abandonment.
So there you have it, folks. It was a challenging well for us, but we learned new things every day. We adapted and we overcame. What do you think, Justin?
You know, it was an absolute honor and privilege to be part of such a complex well. And to see something finished up after 3 decades worth of work, it was my pleasure.
All right, till the next one, brother.